Okay, this is a recording to do problems 180 and 181. I did these on in class, but I'm not quite sure that everything worked out properly in class, so I'm going to do them again. So in 180, I read the problem and I'm looking to see if this is a time spanner. I conclude that it is not a time spanner because what they want is they want the velocity and acceleration at a particular point, and they don't tell me that it started at some point and has moved. So what I'm going to do is look for whether or not this is an r theta, tangent normal, or an xy. Because everything is given in terms of r and thetas, it seems obvious to me that this is a r theta problem. Here's the figure, by the way, that of what's happening with it. And so what I'm going to do is I'm going to work on velocity first, because velocity is by far the easier one. And so I'm going to write down the equations. Velocity is equal to r dot in the radial direction plus r theta dot in the theta direction, or the transverse direction, I believe is what the book calls it. So what I need to find is r dot, and theta dot. In this particular case, they tell me what theta dot is. They say it's a constant of 1.5. So I'll just record that. Theta dot is 1.5. Since it's constant, then I can take a derivative of this and find out that it's equal to 0. They want me to find the acceleration when theta is 60. The thing to watch out for is most likely, well, no, okay, all right. So what I need is r and r dot and all that sort of thing. So I'm just going to start out with what they tell me. R is equal to 4 times the sine of 2 theta. So I know the theta is equal to 60, so I can put 60 degrees in here and I can get r. That won't be a problem. The derivative of r, I'm going to use the chain rule, because this r is not written in terms of time, it's actually written in terms of theta. So when I apply the chain rule to this, I'll get derivative of the sine is the cosine 2 theta times the derivative of what's inside the argument of the theta, which is going to be 2 times theta dot. Since I know theta dot, I can find r dot without any problem. R double dot, I'm going to treat this term as a product formula. So I'm going to say it's, of course I'm going to take the 4 out front. So there's term number 1, and term number 2 is this one right here. Okay, I'm going to take the 2 and the 4 out together. So I'm going to say that r double dot is equal to 8. It's 2 times 4. Put a big bracket here. Factor that out in front. So product formula, I take the derivative of the first term minus sine of 2 theta times the derivative of what's on the inside of that, which is 2 theta dot, using the chain rule, times the second term, which is theta dot, the yellow term, right? And then I finish the product formula plus the first term, the blue term, cosine of 2 theta, times the derivative of the yellow term, which is theta double dot, in the bracket. So I have theta double dot, I have theta, I have theta dot. I can just calculate the number for r double dot. So I can plug in. I know this value, the theta dot term. I know the r, the formula for r, and I have the r dot now, which is taking the derivative. So I can just calculate the numbers. I'm going to use Mathematica to do the calculation, because rather than using the calculator, I'm a little bit lazy. So I'm going to do that with Mathematica. The acceleration, by the way, since they want me to find the acceleration is equal to r double dot minus r theta dot squared in the radial direction plus 2 r dot theta dot plus r theta double dot in the transverse direction. And so I have all the numbers that I can plug into that one. So it's basically just a plug and chug at this point. Okay. Okay, here I have Mathematica up with my customary quit, and I'm going to essentially use Mathematica. Well, as a matter of fact, I'll show you how to take a derivative with Mathematica as well as just using it as a calculator. So again, what I want to do is I'm going to find r, and I'm going to use one equal sign. So I'm going to define r as 4 times the sign. The sign is built into Mathematica. You have to use a capital S. 2 times theta. And theta is a function of time, so I declare it as a function of time. And then I hit enter. So now it knows what r is. I'm going to find r dot as being the derivative of r with respect to time. And then I'm going to find r double dot as the derivative of r with respect to time twice. And so now that I've finished all of my taking derivatives, I'm going to plug in numbers. And so here what I have is theta of time, and that is equal to 60 degrees. The default in Mathematica is radians, so I want to make sure that I tell it that it's degrees. The theta derivative is, let's see, 1.5, and that's in radians already, so I'm okay. And then the theta double derivative is 0 because theta dot is constant. So we'll hit enter on that. So now I know what theta dot and theta double dot are, and so I can find what r dot and what r double dot are, since I have numbers for the others. And I don't like that square root of 3 business, so I'm going to ask for r. I say divide and a capital N, and I'm asking for it as a number, so I've got that as a number. Okay, so now I've got my r's and theta dots and all that, so I can come in and say, okay, the velocity in the r direction, that is equal to the r dot. Let's see, the velocity in the theta direction is equal to r times a theta dot. Excuse me, theta tick. That's the way I defined it before. So those are my two velocity components. The acceleration in the radial direction is equal to r double dot minus r theta dot quantity squared. So that's the AR direction, negative, and then an A theta in the transverse direction is equal to 2 R dot theta dot plus R theta double dot and minus 18. So that's the values of that. Okay, now we're back to looking at problem 181. Essentially, it's the same thing as 180. The difference is that the angle theta is given by formula instead of theta dot being a constant. So the only difference really is trying to find theta, theta dot, and theta double dot. So in this particular case, we're going to write down the formula. So they're told us that theta is equal to 3 times time to the 3/2 power. And so now we take a derivative I do not need a chain rule in this case because theta is given as a function of time. So it'll be 3, and then bring the power down, times t to the power minus 1. So that would be 3/2 minus 1. It's 1/2. And then we'll take a second derivative of that. Theta double dot is equal to 9 over 4. Oops, excuse me, 9 over 2. Let's see, we'll erase that. Oops, 9 divided by 2. Now taking a derivative, I'm going to bring the power down. T to the power minus 1. And so there's the derivative. And now I'm just going to plug in values like I had before. R is the same thing as it was before, so now R, but I don't need a bar over that. R is equal to 4 times the sine of 2 theta, 3t to the 3/2. Now be careful because this angle here is in radians. So when you do calculation, make sure that you're using radians. For example, right here it says that the angle is in radians. So be careful. Make sure that you plug it into your calculator properly. R dot I took before. That one's easy. That's equal to 8 cosine of 2 theta times theta dot squared. So I have theta dot. I can put in the value of time. They tell me, oh, I need time. So let's see. They tell me that theta is 60 degrees. So what I'm going to do is I'm going to put in 60 degrees, convert that to radians. So that's going to be pi over 180. So that's theta in radians equals, and the formula is 3 t to the 3/2 power. So you solve for t. So t is going to be equal to, and then you just simply solve that. So anyway, I get the t. I can take the t, put it into the angle here. So I solve for t, put the t in, and get the angle theta, get the angle theta dot, get the angle theta double dot, and then now that I have theta, theta dot, and all of those, I can get the r dot and get the r dot and the r double dot from before. And get that as well, and then just plug into the formulas, and out pops your answer. So I'm not going to bore you with the mathematics, but well, maybe I will. I'll show part of it at least in Mathematica. So here comes the Mathematica, and what I'll do is right here I'm going to quit. And R is equal to, let's see, what was R? R was equal to 4 times the sine of theta. I believe that's right. Yeah, 4, no, sine of 2 theta. Sine of 2 times theta. And then r dot is equal to the derivative of r with respect to time. R double dot is the second derivative of r with respect to time. So we'll have those, and then we know that theta is equal to 3t to 3/2 power, so it would be 3 times t raised to the 3/2 power. Theta tick is equal to the derivative of theta with respect to time. Theta tick tick is equal to the derivative of theta with respect to time twice. So that's our values. We say that theta is 60 degrees. We want to know what time is, so I'm going to say th of t t equals 60, and that would be pi divided by 180, so I've converted into radians. So there's my formula, and I'm going to solve the previous thing that I executed, which is the formula, solve the formula for time. So there's my time.